Hi guys, today we're going to do a quick review of factoring. So, you might think that you moved past this in grade 9, grade 10, whenever you first learnt factoring, but trust me, there's probably something in this video for you because I'm going to go right from the first type of factoring you ever learnt, common factoring, all the way up to factoring sums and difference of cubes and factoring polynomials with exponents higher than 2 using grouping methods and things like that. Okay, let's start with first things first. So, whoops, okay, there we go. Okay, let's talk about what factoring actually is. So factoring is basically the opposite of distributive multiplication. So here's distributive multiplication. I'd multiply the 2 into the brackets here, and I'd get 2x plus 20. Easy. Okay, if I wanted to take this and factor it, so the method, I would find the common factor of each of the terms and divide each term by it. So the common factor here is 2, so I'm going to divide each term by 2. So I write that outside the brackets. If I've divided 2x by 2, I'm just left with x. If I divide 20 by 2, I'm just left with 10. There you go, easy. Okay, let's try this one. So the common factor here, so every term can divide by 3, and every term could also divide by x. So the common factor is 3x. Okay, let's put that outside the bracket. If I divide 3x squared by 3x, I'm just going to get left with x. If I divide 9x by 3x, I'm going to get left with 3. And if I divide 12xy by 3x, from the number bits, I'm left with 4. The x I've divided out, so just the y stays. There we go, common factoring. Now, since common factoring is the reverse of distributive multiplication, we can check it by doing distributive multiplication. So let's do that really quickly. So we'll check. So my first term, I've got 3x times x, that's 3x squared, minus 3 times 3x is 9x, and 4y times 3x, multiply the numbers and we get 12, there's an x and a y, which is obviously what we had at the beginning, so that's good. Okay, all fairly straightforward so far. Let's move on. Okay, this might be where you start feeling like you need to review. So here's quadratic factoring. So there's broadly 2 types of quadratic factoring. Here we're going to do the type where a is 1. So just a reminder, the format of a quadratic equation is ax squared plus bx plus c. A, b and c are obviously usually numbers, and we just use these letters to stand in for the specific numbers. So a is the coefficient of x squared. When a is 1, in other words there isn't a number here before the x squared, it's a bit easier to factor. There's 2 main methods of doing this. I'm going to demonstrate both of them. Method 1 is easier for these types of quadratics, but method 2 is more useful later, so you can choose. I'll do both to show you. Oops. Okay, so method 1 is list the factors of c and choose ones that add or subtract to give b. So here's the c term, so I'm going to list the factors of it. Oops, I need to write a little bigger than that. So I've got 1 and 20, 2 and 10, and also 4 and 5. Okay, clearly 4 and 5 are the ones that add to give 9, the other ones don't add to give 9. So I'm going to factor this like this, x plus 4, x plus 5. Okay, hopefully you've seen this before. This isn't intended to be a first-time lesson for quadratic factoring, it's supposed to be a review lesson. So I'm not going to go into why this works this way too thoroughly, but again you can check by expanding and multiplying it back out. So a helpful way of remembering how to do this is FOIL. So FOIL stands for first, outside, inside, last. First means multiply the 2 first terms together, x squared. Outside means multiply the 2 outside, so that's the x and the 5. Inside is the 4 and the x. And the last term, 4 times 5 is 20, so that collects and it gives us that. Okay, right, I'm only going to do that once because hopefully you should know a little bit about quadratics here. I'm also going to actually just get rid of that because I'm going to need the space in a minute. Oh, I've got rid of the answer. Okay, let's try that again. So just so we've done that, this factors as x plus 4, x plus 5. If I were to do this using method 2, what I would do is split up the b term. This is called factoring by grouping. So I'm just going to rewrite the question over here so we can try the same thing again. I'm going to split the b term into numbers that are factors of c. So only one of them has to be a factor with c. So what I might do is split this into, let's say I chose, I split up 9 into, I could think of 3 and 6. 3 plus 6 is 9. Neither 3 nor 6 are factors of 20, so that won't work. I could split up 9 into, I could do it into 8 and 1. That doesn't work either. Okay, I'm pretty sure the only way that works actually is 4 and 5 here. So let's do that. Okay, so let's imagine that I've split this up like this. Now, what I do is I take common factors from pairs of terms. So from my first pair, the common factor, I can divide both terms by x, and I get left with x plus 4. From these two terms, I can divide both terms by 5, and I get left with x plus 4. So because these two are the same, really what that means is that both x and 5 have to be multiplied by x plus 4. So we can write that, which is obviously what we know the solution is here. Okay, let's move on. Here's another one. So x squared minus 13x plus 40. So this is a negative sign. I know I'm looking for two negatives because they multiply to make a positive, and this number here is negative. So let's do this one by method 2. So I'm going to split the b term into numbers that are factors of c. So 13 could be split up into 10 and 3, sure about that. 12 and 1, don't know. What about 8 and 5? Let's try that. I'm not sure, but we'll see. X squared minus 8x minus 5x plus 40. Okay. The reason why I went with this one and why I didn't go with any of the others is because I can see that 5 and 40 have a common factor. They can both be divided by 5, so that's a good place to start. Right, common factor of my first two terms is just x, and x minus 8 is what I get. Common factor of these two terms, I'm going to pull out minus 5, and that's going to leave me with x from this term. 40 divided by minus 5 is minus 8. There we go, I've got the same thing. Got the same bracket twice, so that's what I want. So the final answer is x minus 5, x minus 8. Okay, this one, I'm just going to do this over here. I'm going to do this by method 1 again, just so you get to see both here. So I'm going to list the factors of 14. This kind of works well because there aren't that many factors of 14. It's either 1 and 14 or it's 2 and 7. 2 and 7 have a difference of 5. And by the way, I know I'm looking for a difference because of that sign there is negative. So that tells me I've got one positive number and one negative number, because remember the c term comes from multiplying the last two terms, so I know it must have been a positive and a negative. Okay, so in the brackets I've got x and 7, and I've got x and 2. I want minus 5, so that means I have to make the 7 negative, and therefore the 2 positive. There we go, we're done. Okay, that's quadratic factoring when a is 1. On the next slide, here are some practice questions. Okay, so pause the video right here if you need some practice on these. There's 10 of these and the answers are on the next slide. And here's the answers to those. Okay, again, I'll give you, so pause it if you want to check your answers from the previous questions. If I've made any mistakes, let me know in the comments below and I'll try to fix them. Okay, let's move on. Right, here's quadratic factoring where the first term is not, sorry, the first coefficient is not equal to 1. So we've got two methods again, and they are kind of parallels to the two methods that we just did. So the first method is list the factors of C, and this time we also have to list the factors of A because it's not 1 anymore. Basically, we do trial and error in pairs to see which ones work. This can take you quite a long time, but it's also easy to understand what you're doing with this. Method 2 is to do this by grouping, and we split the B term into one number that shares a factor with C and one number that shares a factor with A. This is quite nice because it usually works quite well, but it might be a little hard to get your head around. I'll demonstrate method 1 for the first one because it's easy, and then I'll do method 2 because it's kind of more efficient. And again, with method 2, this grouping thing, we're going to use this later because it's really useful for higher polynomials, like ones with exponents of 3, 4, 5, whatever, that we can't factor usually using quadratic methods. Right, okay, so for method 1, I need to list the factors of the A term. So 2 is just 2 and 1, that's easy. 20 is 20 and 1, 2 and 10, or 4 and 5. And now I've just got to do trial and error. So clearly I've got the first numbers in my brackets have to be 2x and x. I don't have a choice about that. Right, so now I just have to try them. So let's try 2 and 10. Okay, so I'm just going to stick those in there for now, and I'm going to work out what my middle term would be. So I'd have 2x from that bit, and I'd have 2 times 10 is 20, and I'd have 20x from that bit. Okay, yeah, that's not going to add to give me 14, that's going to add to give me 22, so it's not that. Let's get rid of the 2 and the 10. What we'll do now is we'll swap them around. Okay, so that didn't work. Now 10x, 2 times 2 is 4, plus 4x. Okay, yeah, that's going to give me 14x, so that works. Now I'm going to put the signs in the brackets. Again, I'm going to refer to these sign rules, but I'm hoping that you've seen them before. If this number is a plus, I know that when I factor, I've got either 2 pluses or 2 minuses in the brackets. If this number's a plus and this one is also a plus, then I know I've got this, 2 pluses. If this number is a minus, then I've got 2 minuses. If this sign here, if this were a minus sign, then I've got one of each, because a negative times a positive makes a negative. I'm hoping that you've seen that before. If that doesn't sound familiar, you might want to consult a video that's designed to teach you quadratic factoring from the beginning, because this isn't. So I'm hoping that I'm just saying that as a reminder. Okay, let's do this one, and let's do this by grouping. So I've got to split the 31 into 2 terms, one that has a common factor with 6 and one that has a common factor with 40. I also know, because of my sign rule, this is a plus and this is a minus, so I've got 2 minuses. So I'm looking for 2 negative numbers that add to make 31. So for example, minus 30 and minus 31. I'm not looking for a difference like minus 35 and positive 4 or something like that. So, okay, let's group it into 16 and 15. So the common factor between 6 and 16 is 2x, and that's going to leave us with 3x minus 8. And the common factor between 15 and 40 is 5, so that's going to leave us with 3x. I factored out a negative, so minus 8. Perfect, there you go. Okay, so we factored it as 2x minus 5, 3x minus 8. Okay, let's try the second one. So I'm going to group the 29 into terms that have a common factor with 10 and a common factor with 21. So I think, oh, and by the way, I'm looking for 1 positive and 1 negative because that's a minus sign. So I might try, I think I could try 30 and 1. That would be a good place to start. So let's try that. 10x squared minus 30x plus x minus 21. Okay, so if I do the common factoring here, I get 10x and then x minus 3. That's not what I'm going to get from here, so not a good idea. Let's restart that. How else could I group this? I could try, perhaps I could do 35 and 6. Oh, sorry, I would think I would want it to be plus 6x and minus 35x. Okay, so the common factor between 10x squared and 6x is just 2x squared. So then I've got 5x from this term and 3. Sorry, that 5 is looking like a 3. There we go. And then from here I'm going to factor out negative, and then 7 is my common factor. 5x plus 3. There you go. So that's 2x squared minus 7. 5x plus 3. Perfect. Okay, so you can use either method. Personally, I like method 1, but that's because I've been doing method 1 for about 10 years, so I'm not really going to like another method as much. Grouping is often a little bit easier to work with because it does require a bit less trial and error, partly because you have more rules to begin with, because you know that you have to have a number that has a common factor with C and one that has a common factor with A, but you can choose. Okay, there's some practice questions on the next page, so I'll move on to those. Oops, I will not do that. I will move on to those. Okay, so I'll let you pause it here if you want to do these practice questions, and the answers are on the next slide here. Okay, so there's the answers to the previous questions. If I've messed any of them up, let me know in the comments nicely and politely, please. You don't really want to be the subject of internet harassment. And let's move on here. Okay, so this is the bit where if you've been thinking, okay, yeah, I really do know quadratic factoring, this is where you want to start watching. There are some special types of quadratics that are actually easy to factor because they have certain methods. They look hard. So this one is called a difference of squares here. Difference in math, remember that means subtraction. So difference of squares, oh dear, sorry, my handwriting. Difference of squares, it's got 2 squared terms. So what might be helpful is to write what the square actually is in each one. So so the square root of this term is 6x, and the square root of this term is 5. The way that a difference of squares factors, you take the square root and you put a minus sign, and then the square root and you put a plus sign. If you are not sure why this works in this way, use FOIL to expand, and you'll see how this is happening. Okay, that's the difference of squares. This one here is a perfect square. We know it's a perfect square, and I'll tell you why it's called that in a minute, but we can spot it because taking half of the b term and squaring it gives you the c term. Half of 6 is 3, 3 squared is 9, which is what we've got here. Okay, so the really neat way this factors, all you need to do is take half of that term, or the square root of that term, because they're the same thing, and it's this squared. So this is called a perfect square because it's the same bracket twice, because remember this is actually just x plus 3 times x plus 3. That's what it means. Do not, absolutely do not ever take something like this and distribute the squared, like square the 2, and square the x and then square the 3. Squares don't work like that. We cannot distribute exponents. Multiplication, we can do that, but exponents we can't. We have to expand it using FOIL in this way. I'm saying that because tons of people do it. Okay. Here's another perfect square. This one, what we should do first is use some common factoring on it, because each of those terms factors by 4, and if we do that first, it's just going to make it a lot easier to deal with. Okay, so I've got this. Now I can recognise it as a perfect square because half of this term squared, so half of that's 2, square it, I get 4. So we know how it factors. 4x, now this is going to be x minus 2. And I've just spotted a mistake in this one. This is not x plus 3, it's x minus 3. Let me change that. Minus, minus, minus. There we go. Okay, and this one is x minus 2 as well. So see how it doesn't look like a perfect square when it's here? Because if I do half of 16, that's 8, and I square it, I don't get 16, I get 64. But it is a perfect square when we factor out the 4 first, because half of this 4 squared is 4, which is here. Sorry, I know there's a lot of 4s going on. Okay, those are all useful things to remember. Just a quick kind of side note, the idea of perfect squares is also something that we use when we're putting a quadratic in vertex form, which is a process called completing the square. If you need a reminder of that, I might do a different video on it. Don't wait around for it though, because I take ages over these, so maybe go look it up for now, but just a quick reminder. Okay, there's one type of, another type of quadratic factoring. Let's move on to really weird factoring. Okay, that's nice and descriptive. Okay, these are polynomials that have exponents higher than 2. They are quadratics in disguise, at least when it comes to factoring them. Quadratics specifically have the highest exponent as 2, but this can be factored like a quadratic. We can spot them because they have 3 terms, like quadratics, and the second exponent is half the first. So we've got 4, 2, and then just a number term. This is the same thing. We've got 6, 3, and just a number term. So here's how they factor. So this is just like quadratics, but in the brackets, it's going to be x squared. So numbers that make 9 would be -3 and -3, and those add to make 6. So that, in fact, is x squared minus 3, all squared. So this factors exactly like a quadratic, but I've got an x squared term in the middle as well. This one here, if you're really paying attention, you'll notice that I pinched this one straight from the previous page. So it's a perfect square. Actually, I pinched both of these from the previous page. Let's factor out the 4 first, okay? Whoops, sorry. So I've got x to the 6 minus 4x cubed plus 4. Okay, so the way this factors, x cubed minus 2 and x cubed minus 2, because so x cubed times x cubed, reminder, you would add the exponents here, and that's x to the 6. Sorry, that looks like a 1, it's not, it's a 2. And then I'd have 2x cubed from the inside terms, 2x cubed from the outer terms gets me that. 2 times 2 is 4. So really, that's 4 times x cubed minus 2 squared. Or if you really want to be fancy, 2x cubed minus 2, double brackets, all squared, just because we can. Okay, that's all good. Let's move on to some more weird factoring. Okay, this is kind of useful. Here's some formulas for factoring. You should probably just learn these. So we did difference of squares a couple of slides ago. We can also factor sums and differences of cubes. The way we would do this is using these formulas here. So this one is for a difference of cubes. So just like a difference of squares is something squared minus something else squared, this is a difference of cubes, and it factors like this. This is a sum of cubes. I'm just going to draw a cube. It's probably harder than writing the word. That's a sum of cubes. Okay, so I'm going to demonstrate one of each here. So this is a difference of cubes. I know that because of the subtraction sign. When you're using these formulas, it's really helpful to write out what your a and your b are. So that b is the cube root of this, so that's 5y cubed. The cube root of 125 is 5, that's how I know that. The reason why it's helpful to write out is because in this formula, see how we have to do a squared and ab? If you only have these by knowing what they are in your head, you're very likely to make mistakes when you have to do these calculations as well, because it's just a lot to do in your head. Trust me, write it down, it barely takes any longer at all. Right, so the formula is a minus b, so I'm just going to write my a and my b. A squared, so that's just x squared here, minus ab, so that's minus 5xy cubed, plus b squared. Okay, 5 squared is 25. Y cubed squared is y to the 6. But I shouldn't have had the cube there in the first place. Sorry, I have done this all wrong. That's really helpful, because I forgot to take the cube root of the y. Okay, let's start that one again, sorry. So, okay. So I've got my a term and my b term. The formula is a minus b, x minus 5y, a squared, just x squared, minus 5xy, that's the AB bit, plus b squared 25y squared. Oops, squared. There we go. Okay. These look like they might be a pain to factor. They're actually quite easy once you know these formulas. Okay, this one's a bit harder. This is a sum of cubes. So the a term is the cube root of this stuff. So the cube root of 64 is 4. The cube root of x to the 12 is x to the 4. So remember that we are dividing, so we'd be subtracting. Basically, I'm thinking that 3 4s add to make 12, which is how I know that that's the cube root. In the b term, the cube root of 27 is 3. Okay, so the way this factors, first term is a plus b, a squared, so that's 16x to the 8, multiplying the exponents, minus ab is 12x to the 4, plus b squared, 3 squared is 9. There you go, sum and difference of cubes. Those are quite nice. There's practice questions for these at the end of the slideshow. Okay, it's almost our last one here. Factoring higher polynomials by grouping. Okay, this was what I promised you and why we worked so hard on grouping in the earlier slides. We can use grouping to factor relatively painlessly when it's like this. So something like this, you might be confronted by this and go, yeah, I've got no idea at all. But what I see when I look at this is lots of things that can be divided by 5. So I'm going to take groups of the first two terms. So the common factor from the first two terms is 5x squared. That leaves me with x from this term and 5 from that term. The common factor from these is 15. Leaves me with x and 5. Yay, grouping was really easy here. Okay, so that's 5x squared plus 15 and x plus 5. Now you might find that some of these can be factored further. In fact, this one can, because I can common factor out of 5. X squared plus 3, x plus 5. If you want to, you can, well, you can't factor this one any further, but sometimes depending on what you get here, if you get another quadratic, you can factor that too. Whatever, you'll have to decide based on the question. Okay, this one is a little bit trickier. Honestly, you're unlikely to see this on the ACT or the SAT, but I wouldn't rule it out completely, and either way it's useful to know. So what I spot is that, like, we've got an odd number of terms first, so if I'm going to factor by grouping, I probably need to split one of the terms. I also notice that 35 doesn't have a common factor of 4, so what I'm going to decide to do is split 35 into 36, because now it shares a common factor with these, and plus 1, sorry, it should have been x squared plus x squared, because that would still add to make 35, okay, so I haven't really changed the equation, plus x minus 9. Okay, so I'm going to common factor, and I'm going to common factor the first 3 terms. So I think I can take out 4x squared. From the first term, that leaves me with just x squared. From the second term, it leaves me with just x. And from the third term, it leaves me with 4. No, it doesn't, it leaves me with 9, sorry. That wouldn't make any sense. Right, so now you might see what's going on here, because what I've got left from here is just that same thing, x squared minus x minus 9. Right, so when I factor this, 4x squared, I need to put a plus 1 here because I've got one of those brackets. The coefficient of that is effectively 1, we just don't write it. X squared plus x minus 9. Okay, there we go. There's a chance that this could be factored further. This particular one doesn't, because there isn't a factor of 9 that has a difference of 1, so I can't do that, but in some cases you would be able to, so just pay attention if you're supposed to be factoring fully. There you go, a little bit of an introduction to factoring higher polynomials by grouping. Okay, right, here's some practice questions for all the types that we just covered. Pause this here if you want the practice questions. And on the next slide, I'm actually going to do the solutions for all of these because some of them are a bit tricky. And moving on. Okay, I'm going to do sets of a few at a time because I just know I can't fit all my working on one slide. Okay, So this type looks like a quadratic but isn't, so s squared. 56 divides by 7 and 8, and those add to 15, so minus 7 and minus 8. There you go. This one, so I'm going to common factor out a 7 first, and then I've got x to the 4 minus y to the 4. That's a difference of squares in disguise. So it's x squared minus y squared, x squared plus y squared, and, sorry, my 2's look like 3's. This is still a difference of squares, so I've got further factoring to do. X squared, sorry, not squared, that's the point, x minus y, x plus y, and then this one, this doesn't factor further, so we'll just keep it x squared plus y squared. There you go. It almost looks worse factored than it did originally, but that's okay. Okay, this one here is a little bit strange because we've got a negative exponent in here. I'm just going to show you how this factors, and then you'll know if you see it in future. It's probably a bit tricky to work out on your own at the time. So this is x squared plus, sorry, it's not squared, forgetting how this works, x minus x, sorry, x plus x to the negative 1, all squared. Let's expand this out to investigate a little bit how this one works. Okay, so I've got x plus x to the negative 1, x plus x negative 1. Okay, FOIL. First term's x squared, that's easy. Outside term is plus x to the negative 1. Inside term is going to be the same thing. And the last term is going to be x to the negative 2. So I've got my first and last terms. The middle term, x times x to the negative 1, this is really just x divided by x, which is 1. So I've got 2 of them, so that's really 2. So that's how we get our x squared plus 2 plus x to the negative 2. A little bit strange, but technically it's quadratic factoring. Okay, and this one here, this one I'm going to do by grouping because I can see this straight away. These I'm going to get left with x minus 9 when I take out the common factor, and I can see that when I divide 72 by 8, it leaves me with 9 as well. This is where it's super helpful to actually know your times tables, your multiplication tables. I don't care what anyone else has ever said. It makes this so much easier when you can see that 72 divides by 8 to give you 9. I just know that without having to think too hard about it, and I can spot this. If you don't know that little fact, it makes this question so much harder, so it's worth learning. Even if you have to go back, you know, you're in high school, you have to go back and learn them. Honestly, I would do it. Anyway, okay, small rant over. Let's common factor this. So from the first term, I've got x squared, and that leaves me with x minus 9. I've sort of already told you how to do this anyway. Minus 8 is what I'm going to factor out. That leaves me with x minus 9. So x squared minus 8 times x minus 9. All right, there's the first 4. And there's the first 4 again. Okay, here's the second 4. Here is another quadratic in disguise. So this is k squared minus 10. Sorry, not k squared minus 10. Yeah, k squared minus 10, I don't know what I'm doing. K squared minus 10, k plus 9. Sorry, k squared plus 9. There we go. This one here, let's do this by grouping again, because I can see if I factor out 2, I'm going to get x minus 6, which is also what I'm going to get from here. So common factor of the first 2 terms is x cubed. That leaves me with x minus 6. Common factor of the second 2 terms is 2x. That leaves me with x minus 6. So I've got x cubed plus 2x, x minus 6, which really is x times x squared plus 2 times x minus 6 if we want to fully factor. Okay, and this one, okay, this is a difference of cubes. So my a term is 5x cubed, my b term is 2. Difference of cubes formula says a minus b, oh sorry, didn't mean to actually write b there, minus 2, a squared, oh sorry, I've made a mistake, hang on. It is not 5x cubed, it's 5x squared. I keep taking the cube root wrong. Okay, let's try that again. So a minus b, 5x squared minus 2, a squared, 25x to the 4, plus ab is 10x squared, minus b squared is 4. There we go. Okay, and the last set of answers. All right. This one, this looks to me like a grouping one straight away because I can see all those common factors. Let's factor out negative 4x squared from the first two terms. So that's going to leave us with x and then 1. Oops, sorry, didn't mean to do that. Let's factor out 4 from the second set. No, let's not factor out 4, sorry. Let's factor out 16. That's clearly the common factor. That leaves us with x plus 1. So negative 4x squared plus 16, x plus 1, but we're not done because this is a difference of squares. So if I write it like that, just other way around, it's slightly easier to see, so we've got to keep going. That squared is, sorry, square root of 16 is 4, square root of that is negative 2x. So 4 minus 2x, 4 plus 2x, x plus 1. There you go, that's fully factored. I feel like I'm going to run out of space. Okay, this one here, I'm going to factor this by grouping, and I'm going to group in pairs. Little bit odd, but watch. So from the first two, the common factor is x to the 4, then x minus 1 is what we have left. From the second set, the common factor is 2x squared, and we get x minus 1. And the last bracket, I do actually just have x minus 1. So the factoring is x to the 4 plus 2x squared plus 1, x minus 1. This bit is worth looking at because I think it factors further. Yeah, it does. X squared plus 1 squared, because that's a perfect square, x minus 1. There you go. That's really neat factoring. The way I spotted to factor this in pairs was these two 2's here. I originally thought about factoring it in a group of 3 because we'd done that in one of the previous questions that had 6 terms. But then I realised I wasn't going to get the same thing in the brackets, and that I would only do that if I factored in pairs because of these two 2's here. So that was my clue. Don't be afraid to try something, and if you get it wrong, you'll always know because you can always expand to check. So trial and error a little bit here. Last one, this is the sum of cubes. So the a term is 4x4, and the b term is 3. So the sum of cubes formula, I'm trying to write this small, says a plus b, a squared, minus ab plus b squared. There we go, that one's easy to factor. And we are, oh, that's so anticlimactic. We are done. Okay, well done. That was pretty hard work. If it was hard work for me, I'm sure it was hard work for you. So feel free to go back and watch any of the bits that you need more review on, and I hope this has been helpful to you. Thank you.